Hey everyone, this is your Section 1 Part 2 notes. So we took Section 1 back on Monday, and so now we're going to kind of finish the section out with today's notes. So this is where we ended up. So continuing on with a little bit of review, first of all. A few weeks ago we talked about how columns on the periodic table are called groups. They could also be called families, so you might want to make note of that. And then the rows from left to right are called periods. And then each and every element on the periodic table will fall into one of these three categories. Every element is either going to be a metal, a non-metal, or a metalloid. And so, to kind of give you a better idea of that, I found this color-coded periodic table. So you can see everything in the blue is a metal. Everything in the green is a metalloid, and then the yellow are the nonmetals. So as you can see, the periodic table is made up mostly of metals, and they take up the majority of the left-hand side of the table, except for hydrogen. And then you've got your metalloids along that stair-step line, and then all of your nonmetals are going to be to the right of the metalloids again, aside from hydrogen. If I were you, I would definitely take note of these elements that are metalloids. If you know which ones the metalloids are, the metals and nonmetals are easy to identify, because if I know which ones these are, then I know everything to the left of that is going to be a metal, and everything to the right is going to be a nonmetal. So now that we have the different types of elements present on the periodic table, we're going to break it down into its two major categories. The first one is called the representative elements, and they are the ones that are in groups 1, 2, and 13 through 18, which I'm glad that they put it this way on the notes, because if you look up at our periodic table, all of those columns are numbered in that way. However, when I talk about these groups, they will always be groups 1A through 8A for me. So you'll never hear me call column 18 of the periodic table group 18. It's always going to be group 8A to me, or just group 8. So those representative elements are the ones that we're going to use most often, while the transition metals are the ones that we use a little bit less often. And those are the ones that are in groups 3 through 12, or since they're not in representative elements, they get the designated letter B. So they're also 3Bs through 12B. And so that is the entire D block. And the F block is also a type of transition metal. They just have a slightly different name, which we're going to talk about here in a few minutes. So remember that elements are either going to be metals, nonmetals, or metalloids. And so we're going to talk about each of those different groups as a whole, because metals as a whole have a certain set of properties, as do nonmetals and metalloids. So metals, all you have to do is think of an example of a metal. A good one would be copper, for copper wire. It's going to be shiny, a solid, and a good conductor of heat and electricity. So then there are a few specially named metal groups that we're also going to mention, that were mentioned in your quiz. The alkali metals are in group 1, or 1A, if you prefer. They are extremely reactive. We saw sodium outside. We put it in the bucket of water to watch it kind of blow up. And that's important because reactivity of this column is extremely important as well. It's not written, but it's something that you should know. As you continue down the group, from sodium to potassium to rubidium and so on, reactivity becomes greater. So as you go down the group, reactivity increases for alkali metals. Our other special group is the alkaline earth metals in group 2A. They are also very reactive, but not as much so as group 1. They get their name because alkaline is another word for a base, as in acid and base. So when you put these metals in water, they actually produce a basic solution. Continuing on with our special groups, as far as metals goes, we talked about transition metals earlier, that the typical transition metals are the D block, but there are also the inner transition metals, which are those ones in the F block that include the lanthanides and the actinides. So transition metals are in the D block, inner transition are the F block. And another word for inner transition metals is rare earth metals. That's something that you might see, so I wanted to be sure to mention it. So that takes care of the special groups of metals. So we're going to move on to general properties of nonmetals, those ones on the right side of the periodic table. They are basically the opposite of metals. If they're not a gas, they're going to be brittle, dull-looking solids that don't conduct heat or electricity very well. For a good example for yourself, you can think of your pencil lead. Pencil lead is actually graphite, which is carbon. And carbon is a nonmetal. It's very dull and brittle. It's not a great conductor of heat and electricity, but it can do it. And then looking at special groups within the nonmetals, the first one we're going to look at is group 17, or 7A for me. They are also extremely reactive, but their trend in reactivity is the opposite of alkali metals. So as you go down the group from fluorine to astatine, you actually have less reactivity. Fluorine is the most reactive. Halogens get their name because the first part of that word, halo, means salt. And halogens create what we call salts in chemistry by combining with metals. Think of NaCl. Our second special group are the noble gases. They're known for being extremely unreactive. So they got that name when scientists in the lab were working with them and trying to figure out what they could combine them with to make them something usable, and they could not get them to do anything. So they thought of them as kind of those old English nobles that just didn't associate with anyone outside of themselves. So that's where they got their name. Last but not least, we have the metalloids, which sit in between the metals and nonmetals on the periodic table. And it's kind of handy that way because metalloids are kind of a mixture of both as far as properties goes. They're similar to metals in some ways, and they're similar to nonmetals in other ways. So they're kind of, you can think of them as kind of a mix between the two. So that brings us to the periodic table that we know now, with our metals to the left, the majority of the periodic table, metalloids along the stair step, nonmetals on the right. And then we have just one more thing to talk about. And that is valence electrons. So it's a little bit of review. If you recall from Unit 5 when we were doing electron configurations, valence electrons were those ones in the outermost energy level of an atom. So if we just take a look at one of these columns, we'll just use this column as an example. And if we go to the outermost energy level of beryllium, it's going to end with the electron configuration 2s2. And so beryllium has 2 valence electrons. If we do the same thing for magnesium, it's going to end in 3s2, which means it also has 2 valence electrons. If we do the same thing for calcium, it's going to end in 4s2, which means it has 2 valence electrons as well. Are you seeing the pattern here? 2 all the way. So everything in column 2A has 2 valence electrons. So what do you think column 1 has? Yep, you guessed it. 1 valence electron. So as you go across the representative elements, it works out really well. Oh, wait, there's the number of valence electrons everybody has. So that's why I call them group 1, group 2, group 3, group 4, because of this valence electron rule. It just really works out really nicely. So if I were you, I would definitely take note of this, if not sketch it somewhere, because it will be really nice for you in the future. that is the end for notes today, but I do want to give you some directions on your assignment. So if you go up to the front table by Mrs. Duncan, you will find this assignment sitting there. And what you need to do, first of all, is on the back of the front page, there are several directions. My strong suggestion for you to be the most successful is to read through the entire list of directions before you ever start anything. It'll make your life much easier, trust me. And you're going to use those directions to complete this periodic table that's on the next page. And do not forget about the questions on the back after you finish filling out the periodic table. All of this is going to be due first thing tomorrow, so do not waste valuable work time today. Miss Duncan will tell me if you do. I do not need this page when you turn it in, so you can tear off this front page and just turn in this one, especially if that makes it easier for you to do all of your work on the page. So, I will be here tomorrow morning if you have any questions. And sorry I couldn't be here to help you out today. But good luck, everybody. See you tomorrow.